If you have a function that returns a list, and that function would work just as well if you returned a different iterable instead, you could probably turn that function into a generator function. This stop after function accepts an iterable and a value, and it returns a list of all the items in that iterable up to and including that value. Now, right now, our function builds up a list and then it returns that list. It does all the work of computing the items in that list right when we call it. What if we wanted our function to return a lazy iterable instead? An iterable that didn't actually compute its items until we started looping over it. We could turn this regular function into a generator function. To do that, we need yield statements. The yield statement is what makes a function a generator function. Now, as long as we're only adding new items to the end of this list, and we're never modifying existing items in the list or removing items or adding items somewhere else in the list, we could probably replace all of our append calls with a yield statement and then delete our list entirely. So we've just turned what was a regular Python function into a generator function, which means now when we call it, it doesn't actually run the code in that function. Instead, it gives us back a generator object that will do work as we loop over it. Now, one way to use a generator object is to pass it to the built-in next function to get just its next item. But how we usually use generator objects is loop over them to get all of their remaining items. Now at this point, we've exhausted our generator object. We've fully consumed all the items within it, which means if we loop over it again, we'll see that it's empty. So if you have a function that returns a list, and as you build up that list, you're only ever adding items to the end, you can probably turn that function into a generator function by replacing all of your append calls with yield statements.